Making beam axle adapters for a rolling jack. My 4-post lift with a pair of 7,000-pound capacity rolling jacks is a game changer. However, the common round pads that come with rolling jacks or a 2-post vehicle lift do not fit well with beam axles. This is an issue I first discovered on our Jeep XJ Cherokee 4x4. The Jeep XJ Cherokee and Wrangler models have narrower beam axles than a full-size 4x4 truck. The Dana 30 or 44 front axle is a busy setup with either leaf spring perches or lower control arm brackets, shock absorber mounts, and a steering damper mount. Adding to this, the differential center section is offset, cramping one side of the axle housing. At the Cherokee's rear axle, a major obstacle is the staggered shock mounts. By design, rolling jack pads are aligned with each other and perpendicular to the runways. The pads cannot be offset. These challenges are common to many 4x4s and other vehicles that have beam axles. So why are round pads a problem? The sturdy round pads that came with the Katool RJ70 rolling jacks will fit a flat surface very well. They are also okay for lifting some beam axles by their tube sections. However, they will not lift an axle by its shock mounts if the mounts are offset or staggered. Additionally, the rugged Katool RJ70 rolling jacks and similar jacks have sliding platforms that do not come in far enough to reach the inboard axle tube sections, especially on vehicles like our Jeep XJ Cherokee. Again, the round pads work well for flatter lift points or frame rails. Our VW Jetta, with its unibody construction and A-arm suspension, works well with softer round pads. Beam axle vehicles like the Jeep or a 4x4 Ram truck require a better approach. Here's my solution and how I chose to meet this challenge. One lift saddle design that makes sense is found on the Gaither More Safe Air Over Hydraulic bottle jacks. I searched for lift saddles like these that will fit a 1.5-inch inside diameter lift extension. Nothing came up. The closest devices that capture an axle or frame are the lift saddles that fit atop a 12-ton hydraulic bottle jack. Many off-roaders find these bottle jack lift saddles handy for field use. Typically, these portable lift saddles have a sturdy curved top brace and a sleeve that helps keep the saddle from rocking. By design, the weight of the axle or frame rests directly on top of the bottle jack stem. The sleeves are a thinner wall seam tubing and not designed to support considerable weight. They stabilize the adapter and help reduce side rocking when used with a bottle jack. The pressure is between the curved saddle brace and the jack stem. Keeping this in mind, I bought 4 stout bottle jack lift saddles. I ordered a 12-inch long section of cold roll 1045 round bar stock in 1.5-inch diameter. The diameter closely matches the inside diameter of a Katool rolling jack extension. This was my place to start. Although the bar sections were round and on specification, it was necessary to remove a slight amount of material from the outside diameter to fit the extension sockets properly. I set the clearances to fit new extensions. I cut the round bar stock squarely into 3-inch sections, then shortened the saddle sleeves. I chose to weld the sleeve ends to the bar stock and make the assemblies rigid. The stout weld beads and gap fill help reinforce the tubular sleeve ends. The saddles came drilled at the center, and I trued each hole, making them a bit larger in the process. Holes were prepared for plug welding the curved saddle to the flat top of each bar stock piece. Each saddle got clamped tightly to its round bar for welding. This tight fit passes the axle or frame's weight directly to the round bar. The 1.5-inch diameter CR1045 is 91,000 plus PSI tensile strength and stout enough to handle this compressive force load. For this clean steel, I use ER70S6035 wire running 7525 argon CO2 gas through my MIG welder's torch. The Beta MIG 170 was set for welding 1/4-inch plate. This works for both the sleeve end to round bar stock and also for the plug welds. The wire is a minimum 70,000 psi tensile strength, ranging as high as 90,000 psi with quality wire and the right welding method, well suited for the metals used in this project. I allowed the hot welded metal to cool down naturally at room temperature. Again, the load is primarily compressive, so the goal with these welds is to make a solid joint between the saddles and the round bar stock. Plug welding burns thoroughly into the CR1045 bar stock end and the saddle piece. Welds at the sleeve ends keep the saddle stable and square with a round bar stock. The adapters, like the rolling jacks and the 4-post lift, will get inspected regularly for any signs of stress. The saddle adapters were ready for a trial fit. On the XJ Cherokee, there are limited saddle or pad placement points at the axles. If stock link arms were in place, I could use the pads at the base of the lower control arm brackets. Here, the long arm lift kit has heim joints that interfere and do not make a suitable lift point. I did careful measurements before selecting these bottle jack lift saddles, and that paid off. The fit is optimal for the narrow outer axle points just inboard of the axle's C-ends. Tailor-made for the XJ, these saddles will also work well for the larger diameter, wider front and rear beam axle tubes on the Ram 3500 4x4 pickup. At the rear of the XJ Cherokee, the saddles fit neatly just outboard of the shock mount brackets. The axle tubes are accessible there, and the rolling jack sliding platforms can clear the tires as well. This lift position is optimal for wheel service and axle work, serving well at the front end of the vehicle as well. The curved saddles capture the axle or frame more safely. I can raise one or both ends of the vehicle, lifting the wheels and tires above the runways. I shaped, prepped, and spray painted the finished pieces with a substantial coating of ceramic engine enamel, restoring the original look. This paint will be durable. With beam axles, ladder frames, or an automotive X-member frame, the saddles have a major advantage. It's highly unlikely that you'd ever raise the vehicle this high off the runways, especially with the vehicle up in the air. This is strictly for demonstration purposes. For wheel service, there's a notch below this that takes the tires off the runways and leaves plenty of room to remove the tires. This would be sufficient room for removing either of these tires for brake service, wheel, axle service, U-joints, or anything like that. The original flat rubber pads with heavy-duty steel backs will work fine for most contemporary cars and SUVs with unibody construction. They work okay for the frame lifting points on cars, SUVs, and light trucks. When using the flat pads, make sure the vehicle will not slip off the pads. It's great to have an 11,000-pound capacity 4-post lift in these heavy-duty rolling jacks. Like any other equipment, Lift products need to be used properly. Safety is always the primary concern. It would be wise for a manufacturer to make similar adapters for popular rolling jack extensions. If you make your own adapters, be sure of the design. Use the right materials and make safety your #1 priority.